let's take a look here. All right. Now, there are other ways to do these problems. I didn't make the bottoms too ugly. I probably should have made them even more ugly. Because here you can just multiply them. You know they make this. But I really want you to see exactly what it is you're doing when you make LCD. You are giving it the piece that the other guy's got, that guy's missing. He's missing a 2. So now you get 10 plus 3, 13 14ths. Right. Amazing. This one, what number do they have in common? 9. So this would be 9 times 5, 9 times 2. I really want everybody to totally see this. It's got to be desperately obvious that this guy's missing a 2. This guy's missing a 5. Now they both have the same bottom. 2 times 9 times 5. 9 times 2 times 5. They're both going to be 18 times 5, which is 90. Okay. So I get 4 90ths plus 35 90ths is 39 90ths. And what's the last thing I do in a fraction problem?
Simplify.
Try to see if it's simplified. Will it reduce? Yes.
3.
Yeah, 3 can go into both.
13.
I like it.
On our tests and stuff, are you going to be looking for us to be doing that to the denominator? Because I don't do it that way.
I'm not going to give you a problem like this. I'm not going to give you any problems that have only numbers in them, because we're past that. What I'm doing with this is trying to show you the whole idea of LCD is this. And in fact, what's the only way I can do these problems is to do it that way. Break it up, see what they're missing. Does that make sense?
Yeah, it does. But
If I did give you this problem, then I don't care.
You're not going to be like...
You can make a list of 45, 90, and then see where 18 matches. Whatever way you do LCD. I like it. I just wanted to make sure everybody realizes this method exists. And it is the only method you could use to do these. Yeah. This guy, 6 times 7, 6 times 2. So the first guy's missing a 2. This guy's missing a 7. So I get 22 minus 35 over 84. Negative 13 over 84. I like it. Okay, so I want you to start off. This first problem is really like the problems in the front. I got an X thrown in there, but they both have an X. So neither one needs it. So it's sort of like just sitting there. So it's almost like it's not there. What's the first guy need? 7. The second guy needs 2. Why did I put 3? So I get 21 plus 8 all over 14x. So I get 29 over 14x, and that won't reduce, so I'm done. So just because there are letters down there, sometimes they don't mess anything up, because they both have the same letters. It's only the numbers, maybe, right? There will be some problems like that. So, oh, sorry.
Could you have done 21 over 14x plus 8 over 14x?
Sure, of course. And then you get 29 over 14x?
Yeah.
I like it. I like it. I just didn't want to write 14x more than I had to. But either way. So when you get one like this, remember what chapter 7 is all about. Almost every problem, the first step is factor. Yeah. I need to see what they each have. I can see he's got an x minus 3, but this guy's hiding what he's got. Right? So I factor out an x. So I can see what he's got, and of course they both have an x minus 3, so the first dude's just missing the x. Please let that be nice. That's almost too nice to believe. He's missing an x, so you give him an x. Aw. And then on the top I get x minus 2, and on the bottom I just get this business. You're not going to lose anything if you don't multiply this out, because that's actually the better thing to do, is to not multiply this out.
On that one, I didn't even factor, I just threw an X in the first.
Oh yeah, you might be able to see he needs an X. Sure.
It's okay.
I love it. this guy, I always got to make sure I throw this guy in here, because when we have variables, we suddenly think all the rules change. And we're like, let me just add 1. No, you can't add and subtract from the top and bottom of a fraction. If that was true, then 1/3 equals 0. Because I'd subtract 1 from the top and the bottom, I get 0 over 2, it's 0. 1/3 is 0. What the shit? You won 1/3 of $1 million. Here's nothing. Ah. No, that's evil. So, on this one, what's he got on the bottom?
M plus 1.
He's got an m plus 1, and he's got an m. So, of course, they're missing each other. So, this guy needs an m, and this guy needs m plus 1. So, we get 3m. Now, here's what I do with the negative if you want to. You can make it plus a negative. Remember doing that a long time ago? Because then you don't forget to distribute the negative. Negative 4m. Negative 4 times 1 is negative 4. And on the bottom, I got m times m plus 1. So on the top, what do I get? Negative m, I like it. Minus 4 over m times m plus 1. Pow! Yes?
Can you do negative parentheses m plus 4?
Oh, sure. This is the same thing as negative m plus 4 over m times m plus 1. That's the same thing, sure. You don't have to, but if you do, I'm not going to take points off. That's beautiful. Little tear. Oh. But it is true. That's fine. This guy is like actually the classic problem. You break up the bottom so you see what parts they're playing with, and you see what the other guy doesn't have. So I always bring it back to like kids. He's got a dinosaur. I don't have a dinosaur. Oh, here's a dinosaur. So you're trying to keep these bottoms happy. How do you factor this?
3 and 2.
Yeah, 3 and 2, 2 and 3. What about this guy? There's only one way to do 2. 2 and 1. I don't know why I made it all squishy. So what's the first guy need that the second guy's got? X plus 1. What's this guy need that the first guy's got? X plus 3. And I can do the same thing, that little plus negative, so I don't forget to distribute that. So I get, what do I get on the top? I get 5x plus 5 minus 2x minus 6 all over x plus 1, x plus 2, x plus 3. So then on the top, I just got to clean it up a little bit. I get 3x minus 1 over x plus 1, x plus 2, x plus 1. Now, I want to show you something. There's a choice I can make as to how to show you to do this problem. And just in case you guys, so right at this step, right after this step, I could have written it like this, and hopefully you guys see why this would be a bad idea. Where you go? There you go. Focus. Okay. So watch. I could write this as 5 times x plus 1 minus 2 times x plus 3 all over x plus 1, x plus 2, x plus 3. You guys, I could have done that, right? Once I get the bottoms the same, I just put the tops all over that. But then what do you think people will do? In fact, what might some of you do? Cancel. And you can't cancel shit. Why can't you cancel a damn thing right now? So flipping minus right there. Division can't break into that. You can't say, these are gone and these are... No. It's sort of like saying we didn't need them in the first place because you're just killing them. They have to be there to make an LCD. They can't just suddenly go away magically. No. Do you guys see that? That's why I try to get you guys to distribute before you write this down so your brain doesn't even have a chance to go kill those things. I don't know if you guys see what I'm saying. So see how this way I said distribute first and then write down what you get when you distribute. Don't write them down, because your brain is going to say, just kill those. They're the same thing. Why wouldn't you kill them? Well, we know better, but sometimes we'll make a stupid mistake like that. So I'm trying to show you don't let that mistake even have a chance. Maybe. Okay. Okay. So hopefully this is useful to you when you go into 7.4. Last thing for today, I think. Let's do. Did I sign 7.5? I forgot my. Yes. Okay. All right. So let's do an example of this. You guys could have said no. So I appreciate the honesty. I just forgot. 7.5, I call it fracception. Have you guys seen the movie Inception? Did you bring a notebook with you so you can keep notes and go back to it, trying to figure out what this shit's going on? So I call it fracception because it's a fraction in a fraction. Of course, inception is all about dream in a dream. So that what I mean by this is 1/2 plus 1/4. What happened? Everybody all right? All right. Now I'm always worried if I said something that sounds like something else. You got to tell me if that happens. Everybody okay? Yes? Okay. Let's say this is 2/3 plus 1/4. Now that looks disgusting. But to be honest, you look at it as a normal order operations problem. What would you do first? I'm going to divide last. I have to. Right? In fact, I mean, think back to when we had problems like this. 7 minus 5 times 2 over 6 divided by 3 times 7. I do the top, do the bottom. The last thing I do is I would divide. Because I got to know what the top is and the bottom is before I can divide them. Yeah, on the top. So the top is a problem on its own. It's an easy problem, thank God. What's the LCD going to be? No. That's all right. Don't overly do it, guys. So 8's not a bad guess, but 2 becomes 4, so I can stop there, right? So times 2 times 2. So I get 2/4 plus 1/4 is 3/4. What do I get on the bottom? What's the LCD here?
12.
Yeah, so this guy needs a 4. This guy needs a 3. So we get 8 plus 3 is 11/12. Now how do I do this? 3/4 divided by 11/12. Let me write it as I said it. 3/4 divided by 11/12. Yeah, multiply by the shekel. Multiply by the shekel. So you get 3/4 times 12 over 11. And what's the smart way to do this? Cross reduce. So you get 9/11. I like it. So what was the whole point of this problem? If the top can become a single fraction, the bottom can become a single fraction, I then know exactly how to do this. Division is multiplication by the reciprocal. So that's how I would do it. So let's see another one. Let me do one just right out of here. Oh, so here's one that's actually a little bit easier. Well, that's kind of dumb. Let me give you a better one. You guys all right? Oh, I'm really evil on this problem. Why am I being so evil? I don't know, just to make a point. All right, now, I'm not being evil in a direct way here. How do I do this? This is a fraction divided by a fraction, right? So how can I rewrite that? Yeah, so it's 2x minus 4 over x plus 6 times 2 over 3x plus 18. I love it. So it's a little easier than this problem in one way. I only had one fraction on the top and bottom. There's nothing to put together. It was already put together for me. And now I think I heard somebody tell me what to do next. Factor. So how do I factor this? I like it. And how do I factor this? Now, does anything cancel? X plus 6 does not. Why not? Because is one on the bottom and one on the top? No, they're both being divided, so they wouldn't cancel each other because it's the same operation. What's the only way to cancel something is if the operations are opposite. They are both on the bottom, so they're both being divided, so they're not going to cancel each other. It's only on the top and the bottom. That's the only way we can kill things. So this is really evil. Nothing cancels, so it's just 4 times x minus 2 over 3 times x plus 6 squared. You just multiply it out. So I like this problem just to make sure you guys understand. Just because they're the same, they don't immediately cancel. One has to be on the top, one has to be on the bottom. I love it. So let's see. Oh, all right. So you guys try this one. Bless you.
Thank you. So just multiply by the reciprocal. See, that flips over, bam. And then you factor. So how do you factor the top of this?
X negative y.
Good. X minus y.
X plus y.
X plus y. And then that's all that you can really factor. Now what dies? What cancels? X minus y's. Whoa. And 1 y. So what's left alive?
X plus y.
X plus y. And a y. And nothing. Well, what's on the bottom? Sorry.
Y.
No, X. Sometimes that's the hardest step, is to realize what the hell's left. Especially the messier you are, the harder it's going to be to see who survived. All right, one last problem, and then I'll let you out of here. Is everybody cool with that? Any questions on that one?
It's a weird one.
It's a weird one? Let me write this one here. I like this one, if you thought that was weird. I'm going to do this one together because it's a little different. Now look at this problem. Remember, if I had an equation with fractions in it, what could I do to kill the fractions? So like if I had an equation like t over 2 plus 7 equals 5 over 2. Multiply both sides by, in this case, 2. Because I got a left side and a right side. Well look, I got a top side and a bottom side. What's my fraction in them? Over t. So I can multiply top and bottom. And of course we know we can multiply top and bottom of a fraction. Multiply top and bottom by t. So it cancels here, but it has to distribute. So I get t squared plus 5t plus 3. Come back in. All over t squared plus 2t plus 1. Now, does this factor at the top? No. The bottom factors, but the top don't, so I don't even do anything. I'm done. It's never going to cancel. The top can't even factor. That's kind of nifty. So that is actually applicable to a few different problems. Multiply top and bottom by something that will kill the fractions. That makes it immediately better to look at. All right. So that's 7.5. I think it's enough for today. Tomorrow we'll do 7.6, and I think that's as far as we're going to make it through chapter 7. So that's what we're going to be on the test.
How come you have 3 back here?
Oh yeah, because you got 3. See?
See, because the X right here?
No, right here. You got 1, 2, 3. What's your denominators? X plus 1, X plus 2, X plus 3, X plus 1, X plus 2, X plus 3.
No, but like, if you factor this out, you only
Oh,
get
I see.
2
I'm with
and
you.
3.
All right.
So I'm saying, how do you get
I
the
got
X
you.
plus 1?
So when you factor that, this, you get X plus 2, X plus 3. And what's on the top? There was,
Oh, 1, right?
what was on the top? 5. Right. And the other guy factored like X plus 2, X plus 1. Are you with me? So what's this guy missing that this guy's got? So I gave him an X plus 1. That's why I ended up with 3 things. I had 2 naturally, and then I had 1 piece that was missing, and the other dude's missing the X plus 3.
Appreciate it.
I like it.